Decide whether the normal sampling distribution can be used. If it can be used, test the claim about the proportion or the population proportion p at the given level of significance alpha using the given sample statistics. The claim is p is not equal to 0.27, alpha equals 0.05. Sample statistics p hat, our proportion is equal to 0.23, and n is equal to 200. So we want to go ahead and look at this particular problem, and the first part of it says, can the normal sampling distribution be used? And of course we need to find out if the normal sampling distribution can be used. Okay, now we need to go ahead and first calculate what n times p and n times q is, and we will do that by saying, okay, I know that n is equal to 200. How do I know that n is equal to 200? Because that's given right here. And we're going to use p as 0.27. So p is equal to 0.27, which means that q will be equal to 1 minus 0.27, which is going to be equal to 0.73. So we'll find NP first, which will be 200 times 0.27. So this will be equal to 54. And then we're going to go ahead and find n times q, which will be equal to 200 times 0.73. And that'll be equal to 146. And we can see now that both of these are greater than 5. And since both are greater than 5, we can use a standard distribution. Okay, which means that we want to bring in the test statistics, but we will go ahead and bubble this in because that's our answer. So we'll go back into the problem. We'll go ahead and we'll left click in B and click check answer. And then it's going to ask us for state the null and alternative hypotheses, which we will do. So let's go ahead and bring this in to the video or into our notes so that we can look at it. I'll paste that right here. And so we are going to go ahead and state the null and alternative hypotheses, which in this case, if my claim is p is not 0.27, there's only one option out of this, and that's going to be option B. The null hypothesis will be that p is equal to 0.27, and the alternative hypothesis will be that p is not equal to 0.27. So we go ahead and we left click choice B, check answer, move on to the next part of this. And this is determine the critical value. Select the correct choice below, and if necessary, fill in the answer box to complete your choice. Okay, so the next part of this is to do this portion, which is going to be determine the critical value, select the correct choice below, and if necessary, fill in the answer box to complete your choices. So we are going to go ahead and bring in the critical values from the textbook, from the standard normal distribution table at the end of the textbook, which is in page A16. And since this is a alpha is equal to 0.05, that means we'll be looking at a 0.95 confidence level, so Z sub C will be 1.96. But remember that this is a two-tailed test. How do I know that? Because this is a statement that the null hypothesis is equal to 0.27, and the alternate hypothesis is not equal to 0.27, which means that we'll be looking at a two-tailed test. And when we look at a two-tailed test, we're going to be looking at these two areas for rejection areas. And instead of being at 0.05, we'll be at 0.025 as far as the areas to reject. And that means I'm going to have a negative 1.96 for Z sub C. And up here it's going to be a positive value. So in my stat lab you would write negative 1.96 comma 1.96. So you'll see that I'll click into this field, I'll type negative 1.96 comma 1.96. I'll hit enter, and it tells me that I've done a good job. And then I'm going to go on and find the z-test statistic. The next part of the problem states find the z-test statistic, calculate the correct or select the correct choice below, and if necessary fill in the answer box to complete your choice. A, z is equal to some value, round to 2 decimal places as needed, or B, the test cannot be performed. In this particular case, what we're going to do is we're going to use Statcrunch to do our calculations. So when you're in the problem, if you left click this button that says Statcrunch, it will open up another window. This particular window will allow you to use Statcrunch to do some calculations. Now, since we are using a normal distribution, the calculations will be based upon that. But this is a proportion, so we are going to left-click Stat right here. We are going to highlight Proportion Stats, left-click One Sample, not with data, but with Summary. This will bring up this pop-up window. And what we're going to do is we're going to type in the number of successes, the number of observations, and we're going to type in what our P is supposed to be equal to. Now, in this particular problem, if we go back and look at it, we know that P hat is equal to 0.23. And N is equal to 200. This will be our observations, where N equals 200. We're going to put that in as observations. In order to figure out what the number of successes are, we'll take and we're going to multiply the 0.23 P hat times N 200, and that will be equal to 46. And that's what we're going to put in for number of successes. So we'll go back into Statcrunch, type in number of successes 46, number of observations is 200, and don't forget that our P is 0.27. And notice that this is a statement of equality and a statement of inequality. And I can change this if I need to, but for this one we're just going with not equal to. We will left click compute, and this will bring up another pop-up window. So looking at our pop-up window, we see that the z-stat is negative 1.2741826. But remember that we're going to round to 2 decimal places, so we will simply put in negative 1.27. And that's the value that we will put into my stat lab. And we'll type that in right here, negative 1.27. We'll go ahead and check our answer. We get nice work. We click OK. And then we're given another part of the problem to complete. Okay, so what is the result of the test? Well, remember, this is our distribution. And at the left-hand side, we have a negative 1.96, and anything below that is in the rejection region. The right-hand side, we have a z-score of 1.96. Now remember, as I said, these are z-scores. Okay? And we're going to go ahead Okay, remember that our test statistic that we calculated was a negative 1.27, which will be somewhere right about here. And that means that it does not fall in the rejection region. So now that we know this, we go ahead and we decide what we're going to do with the results of the test. We're given 5 choices here. The first one is reject the null hypothesis. Well, obviously we're not going to do that since the test statistic does not fall in the rejection region. So anything that says reject the null, we can just ignore. So we'll ignore that, and we'll ignore that one. And obviously we'll get rid of the test cannot be performed. So we're left with 2 choices. Fail to reject the null hypothesis. The data do not provide sufficient evidence to support the claim. Or fail to reject the null hypothesis. The data provide sufficient evidence to support the claim. Now remember, the claim given originally was the null hypothesis, was the alternative hypothesis. And that was that P was not equal to 0.27, which means that the null hypothesis is P is equal to 0.27. So we will fail to reject the null because the data do not provide sufficient evidence to support the claim, and this will be our choice B. And so we'll go ahead and we'll click here, click check answer, well done, and we have finished.